Welcome back. Let's get stuck into the summary of today's lecture, which was all about psychometrics. Hopefully, in reflecting on today's lecture, you have a good appreciation of the artistry of the science of psychological measurement, which is really what psychometrics is all about. I hope that when you now look at measures in research that you're reading, you start to question whether those measures measure what they are intended to measure, so the validity of the measure, and you ask yourself, can it be done in a better way? So are we really measuring what we think we're measuring? Could it be improved? These are the sort of questions I'm hoping today's lecture imparts upon you. The goal is to validly measure individual psychosocial differences and design and test psychological measures using factor analysis and then reliability and validity to assess those measures. Operationalization, the steps to take. We talked through how it starts with brainstorming the ideas, indicators of a concept, defining the concept, draft your measurement items, pre-test and pilot test. We examine psychometric properties, ask ourselves how precise are the measures, and redraft, refine, and retest over time. And so the exception is if a measure already exists for a construct you're measuring, best to start there and build from that research that's already there. And I gave you the example of, in menopause research, the Stages for Reproductive Aging workshop for women's health was put together to operationalize the definitions for menopause and premenopause and different stages of reproductive aging, and allowed for a better understanding of these particular measures. And so once you understand the measure and have a good definition and operationalization of it, then you can start to progress with using it within research. So that's the key takeaway there. We talked a lot about measurement error, and the key takeaway here is there is something you're trying to measure with, so say a true value, and there is levels of error around the measuring of that value. And so the deviation of measure from the true score is really what we're talking about when we talk about measurement error. And that consists of things like random and systematic error. So the sources of error include non-sampling. So these could be paradigm, respondent bias, researcher bias, or sampling. So the sample is just not representative. And so that could be a source of consistent error. How can we minimize error? Well, we can do it methodologically through well-designed measures, having a sample that's representative. We can reduce demand effects on our participants, maximize response rates through our study, and ensure administrative accuracy when we're inputting the data. So these are all sources of error, and you can see there's multiple points at which error can be introduced. And so our role is to really try to minimize the error as much as possible so that we can ensure we're measuring with as much precision as possible that true value. So when we talk about reliability, there's consistency or reproducibility. Those should be the two key words that come into your mind when you think of reliability: consistency, reproducibility. The types include internal consistency and test-retest reliability. So the internal consistency had split half, odd half, odd even, and Cronbach's alpha. And Cronbach's alpha was the average of the split halves, all the possible combinations of split halves that you could do. And so if there's only two items, then you just compute the correlation coefficient for those two items. The rule of thumb for Cronbach's alpha is less than 0.6 is unreliable, 0.6 is okay, 0.7 is good, 0.8 very good or strong, and 0.9 is excellent. So it gets better as you go up until a point, because when it gets to 0.95 or above, it may be overly reliable or redundant items. So they essentially, you've identified where you have items that measure pretty much the same thing. So it depends on what is being measured. So that theoretical interpretation matters a lot, but you want to aim between 0.7 and 0.9 and keep in mind scale length. So validity, extent to which a measure measures what it is intended to measure. So hopefully that is stuck in your brain now, and it's multifaceted. You can compare with theory and expert opinion, correlations with similar and dissimilar measures, and predicts the future. And so that's the different types of validity. We talked about creating composite scores, so you can use unit weighting, total of items, or average of items, and regression weighting, which is where each item is weighted by its importance to measuring the underlying factor based on the regression weights. So those are different types of ways we could create composite scores. So that is it for today. And I'm not sure if you noticed as we've progressed through this lecture, the lighting has gradually improved because the sun has come out. So hopefully that's a metaphor for the enlightenment that's occurred as you're in this lecture. But if not, remember the journey of the struggle when it comes to understanding statistics, and just keep trying, keep reading, and it'll come over time. It's just consistent practice, and hopefully reviewing these lectures helps a lot. Next week we're going to talk about multiple linear regression. We'll talk about correlation. We'll do a review of that. Because that's foundational to our understanding of simple linear regression and multiple linear regression. And saying that, that's it for today, guys. Have a lovely day, lovely week, and enjoy the metaphorical sunshine for you guys. See you guys.